All right, our next thing that we're going to talk about is what we call summation notation. Kind of reminds me of a Dalmatian plantation from 101 Dalmatians. But summation notation helps us to find a sum. Sum meaning addition, addition meaning a series. We talked in the first video about a sequence is separated with commas, a series is separated with addition signs. So really what you're doing is you are summing up the terms in a sequence, thus creating a series. So this is what we call summation notation. And again, it's finding the sum of a finite sequence. Sometimes it might be infinite, but we'll get there in just a few minutes. So sum, meaning adding. Sometimes we refer to this as sigma notation because of this Greek letter, which looks like an E, but we call this a sigma. So what are we summing? Well, we're summing the terms in a sequence. So to help us figure out what sequence we're talking about and kind of what's happening, okay, I is what we are going to call an index. It doesn't have to be I. Sometimes we'll use N. Just kidding. We're not using N. Sometimes we'll use J. Sometimes we'll use K. Maybe an M. Okay? Some sort of thing to indicate here and here, okay, which term we're talking about. Okay? So this 1 tells you what term to start with. So we're going to start with a certain location. Now, in this case, it says start at the first term, because I is equal to 1. But this might say I equals 3, in which case it says start with the third term. Then this number at the top, N, tells you your ending term. Okay, gives you a location where you're going to stop summing. Okay, so again, you'll see this once we get it all into practice. All right. This does not have to be 1. Might want to write that just so you have it to reference. Okay, it's just that this example of notation has it as a 1. So you can sum a finite series, in which case you're summing from some starting value to a finite end. But you can also sum up an infinite number of terms, in which case infinity is what goes up there. Now, you might be asking yourself, when I sum up an infinite number of numbers, if I add numbers to other numbers out to infinity, shouldn't my answer just be infinity? Like 1 plus 2 plus 3 plus 4 plus 5? That's just getting bigger and bigger and bigger. What about 4 plus 3 plus 2 plus 1 plus 0 plus -1 plus -2 plus -3? Well, that's just getting smaller. We're going to do some work into series a little bit later in this unit, and you're going to find that there are some series that when you add up an infinite number of numbers, you actually get a number. What? Don't worry, we'll get there. Alright, so using this sigma notation, we're going to find the sum of this sequence. So, this is telling us that we are going to start when I is equal to 2, and we are going to stop when I is equal to 5. So we need to find the value of each of those terms so we know what to add. So we're going to start when I is 2. So that means -1 to the second times 2 times 2. That's going to give me 4. A sub 3, so again we're going 2 to 5. So A sub 3 is going to be equal to -1 to the third times 2 times 3. -1 to the third is going to be negative times 6, so -6. A sub 4 is going to equal -1 to the fourth times 2 times 4. This is going to be +1 times 8, so 8. And A sub 5 is going to be equal to -1 to the fifth times 2 times 5. -1 to the fifth is -1 times 10 is -10. So this says find the terms from 2 to 5. Well, we did that. A sub 2, A sub 3, A sub 4, A sub 5. And now we want to add them together. So 4 plus -6 plus 8 plus -10 is going to end up being equal to -4. Okay? How did I get there? 4 minus 6 is negative 2, plus 8 is 6, minus 10 is negative 4. So this whole thing is equal to negative 4. The next one, we are summing from I equals 1 to 6 of k equals 1 to 6 of negative 2k plus 5. Well, to start, let's find each term. So a sub 1, we're starting with 1 this time, is equal to negative 2 times 1 plus 5. So that's going to be equal to 3. A sub 2 is going to be negative 2 times 2 plus 5, which is going to be 1. I'm going to let you go through and find a sub 3, 4, 5, and 6. Okay, so use this. We're going to end at 6 because of that top number. Summing from when a sub 1 to a sub 6, go ahead and find these 4 terms. Okay, hopefully you found negative 1, negative 3, negative 5, negative 7. Well, this doesn't tell us to just find a sub 1 through a sub 6. It says we also need to sum them up. So let's add them. 3 plus 1 is 4. Minus 1 is 3. Minus 3 is 0. Minus 5 is negative 5. Minus 7 is negative 12. Final answer, negative 12. Okay, k equals 0 to 4. So in this case, we're going to need to find a sub 0, a sub 1, a sub 2, a sub 3, and a sub 4. I want you to go ahead and practice that. Okay, so go ahead and pause your video and then we'll compare numbers in just a second. Pause it. Stop waiting for me to write the answers in. Okay, but again, it wasn't just asking us to find the values of a sub 0 to a sub 4. It was asking us to sum them. So 1 plus 4 is 5, plus 7 is 12, plus 10 is 22, plus 13 is 35 is our final sum. Alright, summing from I equals 1 to 4 of 5. Well, now this is interesting because we don't have anywhere to plug in an I value. So that means that a sub 1 is just equal to 5. And a sub 2 is equal to 5. And a sub 3 is equal to 5. And a sub 4 is equal to 5. And I can stop at a sub 4 because it says to sum from the first term to the fourth term. Well, what's 5 plus 5 plus 5 plus 5? 20. Little shortcut, if you want to think about it. This is not something you have to remember, but those of you taking calculus next year, it might be useful. If you are summing just a constant, so just 5, there's no I, there's nothing that's dependent on this term down here, okay, this n value, this I value, this k value. Shortcut would be to just take 5 times 4, which is 20. Because every term is going to be 5, and repeated addition is just multiplication. Okay, so again, just a reminder, this is your index. This is going to be your starting n value. This is going to be your ending n value. And then you want to actually add up, or sum, the terms of the sequence. So first find the sequence. And then go ahead and add up all of those values.